Hey, it's Professor Glenmo here today. A bit of a change. See if I can run these controls that DJ Glenmo's organised. So did you like those tunes? That was the famous Mozzitron's, DJ Mozzitron. So big shout out to DJ Mozzitron. aka Will Hall. It's great to have some proper music, original intro stuff. So yeah, that's pretty cool. So if you're wondering why Professor Glenmo, that's me, is on today, so DJ Glenmo had some family commitments again, had to kind of run children around and stuff, so he sent me instead. And also because I'm kind of the tech guy, so when it comes to explaining complicated stuff, he always gives it to me for some reason. But anyway, there we go. Hey, just let me know if you're hearing the stream loud and clear, and let me know where you're watching it from. It's always nice to know what the audience looks like out there. I can see that people are rolling in, so yeah, must be a bit of interest. And you probably saw in the promo, DJ Glenmo is not very good at this stuff. He kind of posted a URL, then he accidentally started it, then he had to delete it, and then he had to re-upload it. So apparently it's the right one now, but if you're looking at the wrong one, you wouldn't even be hearing me. So there you go. So give me a shout out in the chat, and let me know if all is well. So yeah. Now, what have we got on today? Today, g'day Adam, loud and clear from Perth. Fantastic. Oh, that's great to hear. So thank you, Adam. So if you're wondering what today's all about, it's about a technical specification that is currently being considered by Standards Australia. So let me kind of explain the situation. And don't freak out if you're an installer. It's not a new rule that you have to comply with. It's actually to do for manufacturers who manufacture battery or energy storage products, and it's going to have an impact on them. G'day Scott from Giro. G'day Scott. And so what's the issue with this technical standard? Well, I shouldn't say standard. It's a specification, right? It's a different kind of beast. Maybe I'll show you a graphic just to kind of make it, excuse the pun, rather graphic. So the situation is this. If this technical specification, as it's being published, and I'll show you where you can download it from, it's public at the moment, the implication, in my opinion, will be something like this. You'll just see a whole lot of what people think of as stackable battery systems knocked off the product list. And there's currently these products, there's no safety issue with them, there's no compliance issue with them, but this technical specification will possibly knock them off the CEC approved list. Now, that's freaking out a lot of manufacturers, I can tell you. In fact, a rough guess, when I look at the CEC list, it affects about 30% of the battery systems listed there. And if you think about what market share that is, I'd say that's about 80% of our battery market. Now, this would be an absolutely terrible thing to happen. I don't think there's any malicious intent. I think this is kind of a little bit of an accident, if you ask me. When sometimes things get updated and no one's paying close attention to the details, stuff can go wrong. And sometimes a technical committee doesn't really realise what they're doing. It sometimes is a bit like the blind leading the blind. So, falling into a hole by accident and taking with it something like the battery industry. So there's a bit of silly memes. If you happen to be a fan of Peter Bruegel, the famous painting, The Blind Leading the Blind. Actually, I've been to the art gallery in Vienna where this was, and I pointed at it with my little technical finger, and suddenly over the intercom came, Achtung, Achtung, something about stand back in German. I'm not allowed to point at paintings in case you touch them. So there you go. So, let me just share with you where you can actually view this. G'day, Nuclear Caveman. I like that handle from New South Wales, and Duga from Yamba. Welcome to Toolbox TechTalk. So where can you get this technical specification? I've got to stop calling it a standard because it's a specification for battery storage products. And if I can run these controls like DJ Glenmo set them up, I think it might work. So it's currently available on Standards Australia's website, and if you I just Googled Standards Australia TS5398, and this came straight up. So it was pretty simple. So it's a tech spec, or technical specification, if you like to say the big long words. And its title is Advancing Safety Standards in Battery Storage, launch of the preliminary tech spec TS5398. And if I scroll up a little bit, it tells you a bit more about it, that this is a preliminary publication. So it's rather unusual. It's not actually a public comment draft as you would normally expect. That's coming soon, I believe by the end of this month. This is actually just to give you a sneak peek of the workings of the committee. So take it with a grain of sand. Things may change after this preliminary version has been published. So it's not locked in stone yet. So I guess what I'm doing is just raising the awareness, particularly for battery manufacturers, about the challenges it might bring. Now, you may be familiar with the Smart Energy Council. They have been an amazing organisation at representing the interests of our solar and battery world and further hydrogen as well. And they're right on top of this problem. So I believe that if you're a member of the Smart Energy Council, you could reach out to them. They've actually, I believe, had a webinar last week on Friday, which they recorded, and they're sharing the link to that webinar explaining the problems, but I'm going to kind of do my little best to try and explain it as well. So, you know how I love drawing things. So I'm going to kind of explain this issue with some drawings and also kind of a bit of a story, a bit of a backstory about how we got to be having this technical specification, possibly landing sometime in the near future. We don't know exactly when that might be. So let's get my little overhead thing going here. And if I bring that around this way and put that up there and bring that over there. And okay, so now you've got my little drawing pad available. So let me kind of explain how we get to apply a set of rules to, for instance, install, sell and use a product, particularly in focusing on an energy storage product. And I'm kind of drawing something based on Maslow's hierarchy of needs for all those psychology students out there, which is a kind of a pyramid structure of most important to the least important. And if you think about it, the most important thing is that you actually have to comply with Australian law when you are installing products in Australia. And that's in an Act of Parliament. So you've got to comply with an Act of Parliament, which is enforced in every state and territory in Australia. And that Act of Parliament references our wiring rules. Yeah, that big dog. So AEST, NZS 3000. And that wiring rules has in it a whole lot of references to what they call normative standards. And so normative standards are the other supporting standards that need to be complied with in order to comply with AEST NZS 3000. So let's give an example. For instance, i.e. The battery standard AEST NZS 5139 is a normative standard to 3000. So to comply with ANZS 3000, you need to comply. If you're installing batteries, you'd also need to comply with 5139. Now, above that, we've also got state regulations. So we'll have state-based regulations around energy storage systems. I'll just call it regs. And also there's a organisation which represents all of the energy safety regulations called ERAC. And they also kind of form part of that regulation overlay. Now, if you're installing a system that's connected to an electricity network, then you've got to comply with service rules. So we've got service rules. Okay, so service rules on top of that. And that's service rules usually through DNSP's requirements and state regulations. So you've got to comply with service rules. Now, if you're installing a product that you want to connect to a network, and we'll talk about rebates in a second, it would need to be on the CEC approved list. So you've got to check that product's on the CEC approved list. And if I make any spelling mistakes, it's because I can't talk and write at the same time. So I'm not that smart. And to be on the CEC approved list, the product, if it's a battery storage system, needs to be currently complied with the best practice guide. That means the manufacturer has made a declaration, and it's been checked by the Smart Energy Council that it complies with the best practice guide. Okay, so that's that link there. The CEC will check that to be listed on their approved list, that you actually are complying with the best practice guide. Okay. What happens after best practice guide? Well, you'll still have some incentives out there, such as government rebates that you want to access. So let's say you want to access government rebates, whether they're state or territory or federal. And at the moment, of course, the Cheaper Home Batteries program is the big one that everyone is very excited about, because it's extremely supportive of batteries. And so if we're looking at government rebates such as the Cheaper Home Battery program, there will be rules around that. Now, the installation process, of course, needs to then go to someone who's a licensed electrician to install electrical equipment, and you've got to comply with the licensing requirements in each state and territory. Okay, so we need a licensed electrician, and that licensed electrician, if they're complying with rebates, they will need to also be Solar Accreditation Australia accredited. Okay. Gee, it's a big list, isn't it? See if I can spell it. Yep. Okay, so SAA accredited. Now, get into the nitty-gritty at this point. You actually sometimes have to consider the building code. So the building code might have some rules around where that battery storage system can go, and also known as the National Construction Code. There you go. Then you might even have local government rules. Okay, local government regs. So getting up there. Fire services, particularly if it's in a public area, will sometimes have their requirements have to be met. And if you're from Victoria, particularly if you're in the CBD, fire services definitely have some consideration. And really, lastly, I don't know why they're here, but there's the customer. Can you meet the customer's requirements? So this is a massive pyramid of compliance. So layer upon layer upon layer of things that you have to get right. Now, why have I gone to the trouble to explain all this? Some people think it's like you just tick one box and you're good to go. You've got to meet all of these things to get to the pinnacle, which is to be able to supply to the customer a battery storage system. Right. And there's probably even some other levels, like is there even a location that you can install it? That's another whole story. All right. So I'm going to focus on this one here, the best practice guide. What is the best practice guide? Well, maybe I'll just jump out of this, come back to me. The best practice guide is a quasi-product standard. Now, I think it was published back in 2017, roughly. It was cobbled together rather quickly because we didn't have any product standards for lithium-ion batteries, and they were being installed in homes and businesses without any guidance on the safety requirements in installing lithium-ion batteries. Because back then, we had a battery standard, ASN ZS45, I'm having trouble remembering all my numbers. 4039, 4038. Geez, I can't even remember because we've now superseded it. And that old battery standard was for lead acid, nickel iron, and nickel cadmium. So because that standard was superseded by 5139, we wrote into it that 5139 required compliance for sections 4 and 5 to the best practice guide. So the product itself had to meet the best practice guide. So that best practice guide was written for manufacturers. So it's not an installer's document at all. And it's still available, of course, for free from, if you do a search for battery energy safety best practice guide, I think it's called, you'll find it on the web. that document is only for lithium-ion batteries, and that's been one of the real grumbles about the best practice guide from manufacturers of other storage technologies, ones which have been deemed to be very safe internationally, but they can't access any government rebates. So it's been a big problem. So even, ironically, lead acid, which is a 150-year-old technology, wasn't included. So the CEC approved product list for batteries really only included lithium-ion batteries compliant with the best practice guide. About 2 years ago, the discussion around updating the best practice guide decided to move it away from an industry group to falling under the auspices of Standards Australia as a technical specification. And so the Committee for Batteries, EL005, was given the task of producing a technical specification for lithium-ion batteries and lead-acid batteries. I think the plan was to add more at a later stage, but they're the two that are currently in the preliminary draft. So why is there a problem? Well, for a start, that technical specification hasn't been published. It's only a preliminary draft at the moment. But once it is published and has gone through public comment phase and committee review, it sits out there doing nothing. So you can take a deep breath and breathe out again until it's referenced in ASNZS 5139. Because remember, going back to my little pyramid here, the CEC current approved list currently requires compliance to the best practice guide, not TS 5398 at all. But if 5139 here, if this gets updated, and if this requires TS 5398 for sections 4 and 5, then it'll flow through to the CEC and it will replace the best practice guide as the requirement for battery storage equipment that's deemed to be of a high confidence of safety. So that may not happen until 5139 is updated. Now, when is that going to happen? Well, currently it is actually in the process of being updated, but it's almost at the phase of public comment, so I don't think they'll make any changes to it at this point. But they could throw an amendment in, I don't know, it's probably going to take 6 to 12 months to get an amendment through, but it could happen. So that's one possible avenue. Another avenue, which is probably unlikely but possible, is that because compliance is also required for government rebates to things like the Clean Energy Regulator, for instance, the CER for short, the Clean Energy Regulator often will have its own requirements, and they may ask for TS 5398 to be part of that condition. We don't know, so don't freak out about that yet. That's sort of in their purview. Even to accept or reject it too, they may just say it's not required. So we don't know exactly when TS 5398 might become a problem. Now, you don't actually know what the problem is yet, so I better explain that. And by the way, please feel free to throw some questions at me in the chat. So far, I've had some people say some nice things. I like where they are, and it's loud and clear. That's about all. I could do with a bit more than that. But yeah, I'm particularly interested if you're a battery manufacturer and you're watching this, please throw some comments in there. And because I'm actually making this for you guys, and also just to inform the industry about the state of play. So let me bring up a section from the preliminary draft of 5398 and see if I can make this nice and big. See how big I can make it. Where are we? So and I want that. Okay. So remember I said you can download this now from the Standards Australia and read the whole thing. I'm just focusing on a very narrow part of it. And the narrow part of it is Appendix A. Now, you might think, oh, geez, it's only the appendix, Glenn. Why is that a big deal? Well, Appendix A is to try and define what a battery system is when it's composed of many components that are assembled on site. So we've come up with this, when I say we, the committee's come up with this term called modular assemblies, and that means you've got, say, battery module plugged into battery module, plugged into battery module, plugged into controller or BMS, or maybe even plugged into PCE, power conversion equipment such as an inverter. And all of that happens on site as an assembly. And then when it's fully assembled, it is then deemed to be a battery storage equipment and therefore can comply with Installation Guide 5139. So Appendix A is to try and define the requirements for a modular assembly. Now, just in common speak, that's a stackable battery, something that you plug together and commission. And so it isn't actually a usable battery system until you've assembled it. Now, the previous best practice guide didn't actually have anything about assemblies. It just said something like, or 5139 would say a pre-assembled energy storage system. And the interpretation of that, to my knowledge, was really a bit like an IKEA kit. A pre-assembled system means that you are following the manufacturer's instructions and making no on-site manufacture of components. You're just taking out the Allen key and screwing it all together, like an IKEA kit. You're not getting a saw out and cutting bits of wood and gluing it all together. But it was deemed to be, I think, by the look of this preliminary draft, not sufficient, and so to define it much more clearly. So let's look at two kind of key things to do with isolation and disconnection devices for these modular assemblies. There are two types of connectors that are called up. One is a internal connector between modules or between battery modules and PCE. If I was to think of some brands as an example, for instance, BYD, one of the first to do this, brilliant idea. Basically, just like Lego, you connect your battery modules together. There's no wires between them. There's just plugs and sockets. So that's a type A connector. A type B connector is where you have terminals integral to the battery module, and those are externally accessible, and you would link them together with cables. Probably could even be through a busway, but you connect them together externally. So that's type B. So let's jump back to type A, and it's probably the most popular at the moment is type A. Now, the requirement for compliance to this technical specification is that the connectors would have to be IP2X on those battery modules. What does that mean? It means that using a 12 millimeter test finger, it's a really creepy looking thing. If you've ever seen one, it's kind of articulated, that you can't touch any parts that could be live. Okay, so no accessible live parts with a standard test finger. Now, already there are lots and lots of battery modules out there that you can measure a voltage on the terminals, and they're not fully IP2X. They might be slightly recessed. That might be IP 1.5, but that's not good enough. Or they may have terminals that are exposed, but really difficult to get to touch both of them. For instance, there might be one on the bottom and one on the top, particularly with series connected stackable modules. And so that's going to knock out quite a few products that are currently on the CEC approved list. Point number 2 is the connectors de-energize state automatically or manually. What does that mean? Well, it means that there is no voltage, even if it's IP2X, i.e. you can't touch anything. Additionally, there is no voltage on those connection points. See, Simon just asked a question in the chat there. Adding IP-rated connectors and overcurrent protection seemed a reasonable safety feature. Yes, Simon, I'll get to parallel connected ones where definitely, I would agree personally that that's a very important thing. When you start paralleling batteries, you can have some faults between battery modules. But, it is just in my opinion. So, I'm not a regulator or anything. I'm just a, professor of kind of random ideas. So de-energization, that's another issue that would be a major challenge for a lot of the existing products, to be no voltage measurement capable on any of the terminals as you're assembling it. Now, I should point out, this is all about assembling by a licensed electrician. This is not stuff that's accessible to the homeowner or end user. We are talking about trained electrical workers who, currently work on things like switchboards, which may have a live feed coming into them. I mean, if I was to say the equivalent for AEST 3000, if you were to require complete shutdown of an installation before you took the cover off a switchboard, that's kind of the level we're talking about here. And the de-energization may be automatic or manual. So, for instance, just by the fact that it's not connected to another battery module or BMS, it will be de-energized. Or there may be a button on each battery module that pressing will de-energize that battery module. Now, there is a safety logic to all of this, is that you're taking away every possible risk of short circuit or electric shock. I guess my concern is that how far are we going with this? We're not talking about homeowners playing with things or touching stuff. We're talking about licensed electricians assembling something following manufacturer's instructions. Okay, so that's type A. Let's jump down to type B. Now, this is where you have terminals on a battery module, and those terminals are externally accessible but integral to the product and need to be connected to subsequent either series or parallel modules. Now, you'll note there it says point 1 is the modules are connected in series. Oh, okay. So this clause, A.4.101b, only applies to series connected type B batteries. So in the series connected, once again, IP2X on all of those terminals and de-energization on all of those battery modules, either manually or automatically. But let's say your battery modules aren't series connected, they're parallel connected. So you've got a stackable system with parallel battery modules. Then you jump down to the bottom of this document and you'll see if conformance to items A and B above as relevant to the type of device is not obtained, so you're not a series connected, therefore parallel, you need to have internal isolation within the product, and you need to have overcurrent protection. That's mentioned elsewhere. But anyway, both isolation and overcurrent protection will kick in if you're not a series connected. Now, I think this actually does make sense, particularly when you've got cells with potentially high fault currents and you have one cell go faulty and suddenly you've got a massive reverse current from one battery module to another. So if I just jump to another picture I want to show you. So I'll show you a parallel connected system that would be compliant because it does have integral overcurrent protection and isolation. In fact, it's right behind me here in the lab, and it's from Power Plus Energy. So Power Plus Energy have been for ever since they started manufacturing their modular batteries, have put circuit breakers, double poled, overcurrent protection and isolation on every battery module. And because those battery modules connect within their supplied cabinets to a bus bars at the rear, they are potentially, interacting with each other. So if one was to be faulty, there would be some potentially reverse current. But of course, they've got that integrated circuit breaker, which will trip and stop any dangerous thermal overload or runaway. So that is a compliant configuration for a parallel connected system. So Simon, you can calm down now. But let me show you another example, and these are ones from the lab here. So I'm going to bring up another one. So this next one is a alpha ESS system, and this is their Smile G3, I think, from memory. So let's bring that up. So it's got 2 battery modules at the bottom there and an inverter at the top. I've taken the covers off the side. So they're actually, all those cables are mechanically protected. There are covers and you need a tool to remove the cover. So all those cables are normally out of sight and fully protected. I can show you a picture of them fully enclosed. So those battery modules are in parallel. So we need to have isolation and overcurrent protection on each battery module, which they do. So if you look closely at the middle battery module, there's a 4-pole circuit breaker which provides both isolation and overcurrent protection. And additionally, the requirement too is that the cables connecting those parallel battery modules are keyed so that you can't accidentally reverse them. And that's they'll be using Amphenol or MC4 type connectors, which provide that keying. So to my opinion, I'm just really caveat here. Well, this is my opinion. I'm not testing this product to the technical specification. Well, not yet. So that's a compliant parallel battery assembly or modular assembly. But where it gets a bit tricky is when, and I'll jump back here. I see another comment from Simon. I still feel in stacks in the event of either manufacturing fault or mechanical damage, dropping, etc. I'm not sure what you're feeling there, but I think you're saying there could be a fault. Okay, so just a note, Simon, when you put a comment in there, I get to read it very quickly, so I haven't got my full thinking cap on, trying to understand the logic of your statement. So, yeah, sorry about that. Yeah, I actually should show you this system before I go, which is the, before I go on to something else, which is that Alpha ESS Smile G3. And you'll notice that all of the cables are mechanically protected. I should point out, this has been in 5139 ever since it was published, is that all of the battery cables need mechanical protection. You can't have battery cables just dangling down the side of a product. So quite a few systems that have turned up at the lab, we've had to manufacture covers over the battery cables, particularly when it's a combo of a battery system with a separate inverter and there are cables between the battery and the inverter. And there's, Amphenol type connectors on the bottom of the inverter and likewise on the battery module. Those actually need to be protected mechanically. So we've had to build basically, bent metal enclosures to cover them all, whereas Alpha's actually done this already with their side enclosures. So hats off, very, very good. Simon, you're good. Does the proposed technical specification require keyed battery connectors? You probably want to have a little read of this, Simon. Off the top of my head, I can't remember the clause, but I'm pretty sure that there is requirements for connectors that cannot be misconnected. So keying is one way of doing that. So yeah, sorry, Simon. And back to me again. Where are we? So I wanted to show you one that is a bit of a problem with the technical specification. If I can find it. Oh, no, I can't because I haven't got a picture of it. Oh, that's a bit bad. Maybe I'll just have to talk to you about it. Okay, so, and by the way, I'm not picking on manufacturers to say that the product's bad or anything. It's just pointing out the different ways that this technical specification can be applied and where it might be a problem. Now, some parallel systems, battery modules that are in parallel, are paralleled via a DC-DC converter. Now, a DC-DC converter will take particularly extra low voltage battery. It might be, 30 volts or so in the battery module and step it up to the DC bus voltage that the PCE requires. And that DC-DC converter is effectively a barrier between the cells and their potential fault current and the DC bus. And I know from having looked at the circuit diagram of some of those systems, they even include galvanic isolation within the DC-DC converter. So there is actually no current path except when the DC-DC converter is energized to pass transformed voltage and current from one side of the battery cells to the DC bus. But those are in parallel. And so they would have to have overcurrent protection and isolation either internally or externally if they use external cables, so a type B connector, to parallel together multiple battery systems. And I think that's where a big problem lies, particularly when you have effectively met some of the requirements of a modular assembly with a type A connector, such as de-energization and IP2X, but because you're in parallel, then you fall under the requirements for overcurrent protection and isolation. And even though that DC-DC converter may well provide exactly that, because it's maybe interlocked with a separate control circuit, so the moment you disconnect one battery module from another, the DC-DC converter turns off, and therefore there is no current path because it's galvanically isolated. That is not addressed in this technical specification. So it's kind of one of my concerns about it. It's a little bit too broad in its interpretation of what parallel really means. So that's one thing. All right, so I've explained for modular assemblies some of the challenges. The next document it's still from the technical specification, is to do with nameplate designation and ratings. Now, this is probably not such a big issue, but it's just one that manufacturers should be aware of. And the requirement is that there is a permanently affixed nameplate on each component. So each battery module and each piece of equipment as part of that modular assembly, and it needs to state what the maximum voltage and current is. Now, if you drop down to that second highlighted section there, I'll just read it out, where the EES, electrical energy storage equipment, has a leader follower configuration. Now, if you're going to go, what is a leader follower? Well, to be sensitive to, culturally sensitive, the terms master and slave have some very negative connotations politically. And so we're trying to use more generic, less inflamed language now in our standards. So leader follower is the kind of more PC version of master slave. Now, leader follower configuration, the leader shall be marked to the requirements of item A to F. So A, identifying a single unique model designation, be marked in a way that distinguishes the maximum electrical rating from any other marking, be the maximum electrical rating for connection to the electrical installation, so its power output of its PCE, for instance, include for equipment with DC output for connection to the installation, so if you've got a DC coupled battery to a PCE, include for equipment with AC output to connection to the installation, it should say the AC volts, frequency and current, and if include a relevant, as relevant, these ratings for single or multi-phase, or for both, where the EES equipment can be installed in single or multi-phase or both. So, yeah, the labelling, just, in real simple terms, is every component of that modular assembly that stores energy or converts it needs to have a permanently affixed nameplate label that covers points A to F. So, yeah. Now, where things can be a bit tricky is often this is a requirement of a test standard as well. So for the product to be tested and approved for things like the CEC product listing, that will have to go through a test lab. So just slapping on some stickers might actually mean you've got to resubmit your product for testing. And if you're not familiar with that process, it can be very expensive for manufacturers. It can also be very time-consuming because there's often a whole bunch of manufacturers all want the same test done if something like this comes along. Okay, what can I see here? Trevor. G'day, Trev. Hi from the Smart Energy Lab. Trev says the current CEC battery list does not include voltage or chemistry. That's right. So that is true. And you may, I can't speak for the Clean Energy Council, but they may have some more columns to add to their approved list should the technical specification come into force. So there you go. Questions? Come on. Have you got any questions out there? Because what we don't want to happen is that this just rolls through the public comment phase and we end up with something like, hang on, where are we? End up with something like this happening, just basically knocking out 80% of all the products currently being sold into the Australian market without anyone noticing that this was going to happen. So I guess that's kind of my motivation, is just be aware, be alert. If you have a chance to provide a public comment, and how that usually works is that there's a public comment period, and I'll be sure to let you know as soon as that is available. You normally have something like 3 weeks or so to submit public comments. I recommend that you do it in a very strategic way, which is you don't say this is stupid, it'll shut down our industry. That isn't a public comment. You have to go to a particular clause. You have to state why it's inappropriate or needs correction, or even if it's a typo, and suggest a correction and justify that correction. Because what will happen is those public comments will go through back to the relevant committee, in this case EL005. They will review those comments, accept, reject, or modify those comments. And if there is no significant changes to the draft public comment version, just minor changes as based on some of those acceptances or modifications, it will go through to publication, typically within another 6 weeks or so. So it can happen relatively smoothly, but if there is significant modification to that public comment phase, then it often has to go to another round where the modifications are then republished and there is a second round of public comments. That's pretty rare. It's pretty rare, but it can happen. Also, the standards committees actually require a consensus to approve a standard or a technical specification being published or going to public comment phase. And that process actually requires, now if I think I remember this correctly, at least 70% of the voting members of the committee need to vote 80% in favour. There's two sort of percentages. So you can't just be like 3 members of a 10-member committee all approve it, no one else voted. No, it's got to be a significant proportion of the committee actually vote, and usually it's the role of the project manager for that committee to run around and get everyone to vote, because some people are a bit slack. And who are these people, by the way? Well, you can't find out exactly the person involved, but you can see who the stakeholders are. So if you go to the Standards Australia's website, and you can look up to see what the committee members are, stakeholder representation is, and see if I can look one up for you while I'm doing this. And it's going to take me a moment. So yeah, you can find who the representative organisations are, which we call stakeholders. Typically they're things like regulators, industry bodies, government are typically stakeholders, but manufacturers can also be observing members. Okay, I found it. So, for instance, EL005, which is the committee looking after this technical specification, has about 20 plus members, which are what we call contributing members, and contributing members get to vote. So they are Australasian Fire and Emergency Service Authority, Australian Industry Group, Cleansea Council, I'm going to skip a few, CSIRR, Deakin University, Electrical Compliance and Testing, Electrical Regulator Authority Council, which is ERAC, Energy Networks Australia, Energy Storage Council, Engineers Australia, Institute of Electrical Inspectors, blah, 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 Master Electricians Australia, Smart Energy Council. So, yeah, they're on there as well. So those stakeholders get to vote on whether a standard or technical specification actually can go to publication. Generally, it's a pretty smooth affair unless there is a major schism. So let's see how we go with any possible changes to this preliminary draft that is currently being circulated. For those who joined late, let me just show you how to read it, because it is public. And you can go to Standards Australia website and read it. So if you just Google Standards Australia TS 5398, you'll find it. So there you go. That's the website where you can download it from. If you scroll, I'll scroll down a little bit, and there's a link at the bottom there. Download the preliminary TS 5398. So there you go. Okie dokie. Wow, geez, we've got a lot of people watching this. I'm just checking for any comments. So Love the 359er, Garth. G'day, Garth. I have just jumped on the stream 10 minutes ago. I assume the proposed change is not retrospective. Correct. In fact, it's pretty much never do we have retrospective changes, like you have to go back to an existing installation and change it. It's when you modify it that usually a new publication has to be applied. But remember, this is a manufacturer's technical specification. This is not an installation guide. So, for instance, I'm just trying to think of a scenario. If you've got a system that might be upgradable, you can add more battery modules to it, and this tech spec has come into force, then adding another battery module to it may mean that the system might need to be certified to this tech spec. That's my guesstimate. I don't know if that's true. Next question, as in if I add batteries to my current stack. Oh, exactly. Yeah. Daniel says, hi Glenn, would there be grandfather provisions, i.e. current systems items on the CEC be event? Be something, yeah. I don't know. So things like grandfathering is under the purview of the organisation that regulates something. So, for instance, the Clean Energy Regulator may deem that grandfathering of systems that are currently compliant to the best practice guide, even once the tech spec is adopted, may well be okay. We don't know. These are all uncertainties. I'm sorry for giving you a lot of weak answers, but I can't read the future. So Daniel just said answered above. Yep, good. Okay, wow. Now, since there's a huge amount of interest in this, I should reiterate that if you're a manufacturer, and I'd highly suggest that you are a member of the Smart Energy Council, because they're doing an enormous amount of work to try and sort out this problem. They're very aware of the problem, and they are doing their very level best to talk to the authorities that can influence this technical specification to get a more reasoned outcome for the industry. The last thing we want to see is 80% of all the products that are currently being installed just being effectively made non-compliant. It's a major concern. So I'll keep you updated, and I think DJ Glenmo might have something to say about this on one of his next live streams. Maybe he'll get some guests to come in and talk about it. But things are happening very fast. So this tech spec really only a matter of a few weeks ago suddenly got a rocket put under it in terms of how fast it had to be rolled out and moved to publication. And so it's caught a lot of people, a lot of manufacturers on the hop. Yeah. G'day, Adrian. Good to see you there. Adrian says, I'd suggest equivalent level of safety and performance would come into play. Let's hope sanity does prevail, and that would be a very good outcome. Since I mentioned the Smart Energy Council, they've actually got a gig in like a little expo in South Australia. I think it's next week. So yeah, if you happen to be in South Australia, you can go along and kick the tyres, listen to some interesting and informative presentations, and get to talk to a lot of the companies that sell these sort of products. Maybe even grumble about this tech spec. So I think that's really all I wanted to cover today. It has been quite a long and rambling presentation on a very, very narrow topic. So that's why DJ Glenmo got Professor Glenmo in here, that's me, to explain all this to you. So I think that'll have to wrap it for today. And thanks to everyone for tuning in to another Toolbox Tech Talk with whoever might be sitting in the chair and rabbiting on. So, I think it's time to go. And by the way, big thank you to DJ Mozitron for providing our intro and outro music for today. So here we go. DJ Mozitron, you rock. If I can get him to rock. There's always one more button to press in this world. And, can we hear something? Yes. Hey. See you next week. Yeah.
It's just another day. Like any other day.